All right, let's dive right in. The semiconductor world right now, here in 2026, is caught in a massive paradox. We're seeing an AI-driven boom on a scale we've never witnessed before, but it's happening at the exact moment the global supply chain is starting to creak and crack under the pressure. So, what's really going on? And this is the paradox we're all living through. On one side of this seesaw, you've got this absolutely staggering $650 billion build-out for AI infrastructure. It's just incredible. But on the other side, all that growth is putting so much strain on the supply chain that it's creating choke points and fractures everywhere. It's kind of wild, right? The boom is so big, it's actually threatening to break the very foundations it's built on.
So the big question is, how is the industry dealing with this high-stakes situation? Well, the first major move is a complete rewire of the global supply chain. And we're not just talking about building a few more factories here and there. No, this is much bigger. Geopolitics and massive investments are literally redrawing a map of where our chips come from.
And if you're wondering how serious this is, wow, the enforcement is severe. Just look at this. Equipment giant Applied Materials got slapped with a massive $252.5 million penalty. Why? For shipping ion implanter systems to SMIC in China. The Commerce Department claims they used a dual build process, basically building the gear in one spot and shipping it through another to get around the new export rules. This isn't just a fine, folks. It's a giant flashing sign that says these new rules have very real teeth.
It's not just about penalties either. Governments are getting surgical in how they reshape trade. Take the new US-Taiwan deal. You look at the table and it seems great, right? Lower tariffs, more Taiwanese investment in the US. But then you get to the fine print. That last row, that's the kicker. The most critical, cutting-edge semiconductor tech is completely excluded. It's a crystal clear strategy. Collaborate where it makes sense, but fiercely protect the crown jewels of your tech supply chain.
And this rewiring is happening all over the globe. Over in Europe, the new government in the Netherlands is signaling a much tighter grip on chip tech exports to China. At the same time, you've got new players rising fast. India just fired up 4 new chip plants, and their goal is ambitious. They want to produce 75% of their chips right there at home. In Singapore, it's quickly becoming the go-to safe haven for Taiwanese tech firms looking to move operations out of China. The entire chessboard is being reset.
So what does it cost to play in this new, complicated game? How about $45 billion? That's the record spending package TSMC's board just approved. And let's be clear, this is not a routine expansion. This is an aggressive, all-in bet to build enough capacity to navigate all this geopolitical chaos and supply chain volatility. It really just shows the kind of financial firepower you need to lead the pack these days.
Okay, so that's the geopolitical pressure cooker. Now, let's talk about the second major pressure point, and this one is purely technical. While the politicians are redrawing maps, AI's insane, unending appetite for data is creating a full-blown crisis in the memory industry. And if you want to understand just how serious this crisis is, you don't have to look much further than this quote from Goldman Sachs. The DRAM supply shortage is the worst in 15 years. I mean, that says it all, doesn't it? The problem is simple. AI models just keep getting bigger and hungrier, and they need more and faster memory than the industry can physically produce right now.
And you know, basic economics tells you what happens next when demand skyrockets and supply can't keep up. Yep, prices are set to just explode. Projections show that by the middle of next year, 2027, DRAM prices could jump to nearly 4 times what they are today. We're not just talking about a little price hike. This is a market shockwave that is going to ripple through everything, from huge data centers all the way down to the phone in your pocket.
This shortage has kicked off an absolutely frantic race in high-bandwidth memory, or HBM. That's the lifeblood of modern AI accelerators. I mean, innovation is moving so fast that development on HBM5 and HBM6 is already happening. But the pressure is just immense. We're hearing NVIDIA might have to relax its specs for HBM4 simply because suppliers are struggling to make enough of it that actually works. You've even got China's CXMT dedicating a huge part of its production to HBM3. The ripple effect? A total supply chain nightmare. Designers in South Korea are now facing year-long delays just for advanced packaging. A whole year. So with geopolitical maps being ripped up and a memory crisis raging, how are the foundries, the folks who actually build this amazing technology, responding to all this? Well, that brings us to the flat-out race to manufacture tomorrow's chips. Right now, the main event is the heavyweight battle for the 2-nanometer node. And the 3 big players,
TSMC, Intel, and Samsung each have a totally distinct strategy. You've got the reigning champ, TSMC, using its massive war chest to just try and outbuild everyone. Samsung is kind of fighting on two fronts, pushing its 2-nanometer plan while also locking in key orders on other nodes. And then you have the challenger, Intel, which is betting the farm on one key technological advantage to leapfrog them both.
And that big bet from Intel, it's called Backside Power Delivery Network, or BSPDN. And honestly, this is a really big deal. For decades, the power wiring and the signal wiring have been fighting for real estate on the front of the wafer. What Intel is doing with its 18A process is moving the entire power network to the back of the wafer. This frees up a ton of space, improves the signal integrity, and boosts performance. It's a fundamental shift, and it just might be the game changer they've been looking for.
And the innovation isn't just in manufacturing. This is really fascinating. Qualcomm has officially taped out, that means they've finalized the design, for a 2-nanometer chip. But here's the twist. It was designed in India. This ties right back to those geopolitical shifts we were just talking about. It's proof that rewiring the supply chain isn't just about where you build the factories. It's also about the rise of these powerful new global hubs for cutting-edge design talent.
You know, all this pressure, the political maneuvering, the supply shortages, the intense competition, it's acting like a crucible. And out of that intense heat, the next frontier of innovation is being forged. So, let's take a quick peek at what's starting to emerge.
To solve that memory crisis, companies are already looking beyond HBM. Intel just showed off this really cool prototype they're calling ZAM, or Z-Angle Architecture Memory. It's a pretty radical new design that's all about delivering breakthroughs in thermal and compute performance. It's giving us a little hint of what a post-HBM world might actually look like.
And there's so much more coming. We're seeing the convergence of photonics, that's using light, with semiconductors, all because AI needs more and more speed. On the equipment side, new kinds of bonders are being developed right now just to make HBM5 and HBM6 physically possible to build. And we might even see a pivot to totally new kinds of memory, like high-bandwidth flash, to meet different kinds of demand. The innovation pipeline is just packed.
So as we watch this whole incredible story unfold, it is crystal clear that the old rules are gone. For decades, the ultimate kingmaker in this industry was pure manufacturing prowess. That was it. But here in 2026, the game has completely changed. Having a shrewd geopolitical strategy is now just as critical as your technical innovation. So the question is, what's going to be the ultimate kingmaker going forward? The winners of the next decade will almost certainly be the ones who can master both. It's a lot to think about.